This video is about more area of 2D figures. So we're going to look at circles and regular polygons today. So remember from the last chapter that the circumference of a circle is the distance around the circle. The formula is d pi or 2 pi r. D pi, remember, means the diameter times pi, or we can do 2 pi r. The area of the circle is the space covered by the circle, and the formula for the area is pi r squared. So in number 1, we have a radius of 19. So to get the circumference, we're going to do 2 pi times 19, which gets us 38 pi centimeters. For the area, we're going to have pi 19 squared. Remember that we're only using the 19 squared in the calculator, not the pi. So we get 361 pi centimeters squared. Now, in number 2, 52 is representing a diameter, so it bisects into 26 and 26 for the radius. So the circumference is really easy because they give us the diameter. It's just 52 pi inches. To get area, it's pi 26 squared, which is 676 pi centimeters or inches squared. Polygons. So when we're moving with polygons, this is a shape we haven't really talked about yet. In a polygon, a regular polygon is a polygon that has congruent angles and congruent sides. So for example, this would be a pentagon and it would have 5 congruent sides and 5 congruent angles. The central angle is the angle whose vertex is at the center of a polygon. So if I draw a triangle in to one of the sides of my pentagon, this angle up here at the top is the central angle. So to find the measure of the central angle, it's going to be 360 divided by the number of sides. The radius is going to be one of the sides of the triangle. So it is drawn from the center of the circle to the vertex of the polygon. So right here, this would be a radius. And then the apothem, which is important to help us finding the area of a polygon, is drawn from the center and is perpendicular to the side of the polygon. So when we go from the center to the side, this would be the apothem. So to find the area of a regular polygon, the area is going to be equal to 1/2 times the apothem times the perimeter. So let's practice with a bunch of different polygons to find the area. So the apothem, remember, is going to be perpendicular from the center to the side. So to find it, what we're going to do is we're going to divide it into the number of triangles, and we're just going to use one of the triangles. So in this case, each one of these has a triangle with the apothem drawn into it. Then we're going to find the central angle and divide by 2 because the apothem is cutting the triangle in half. And then we're going to find the side length that we need in order to find the area of the triangle, or the area of the hexagon, of the polygon. So find the area. Number 5, a regular hexagon has a perimeter of 60. So if the perimeter is 60, when we divide by 6 sides, each side is going to be 10 centimeters. So what I'm going to do in the hexagon is I'm going to draw my triangle in. And then I'm also going to draw the apothem in. So to get the area, we know that there's 360 degrees. We divide by 6 sides. That gets us 60. But then we're going to also divide that by 2 because of the apothem. So the angle up top here is 30 degrees. So to find the length of the apothem, I know that the apothem bisected the side into 2 congruent parts, 5 and 5. So now I have a 30, 60, 90 triangle. So if I want to draw that bigger, just so I can see a little bit better, I have my triangle, 30 degrees, 60 degrees, this side's 5. This is my 90-degree angle. So remember that the apothem is the side that's forming the right angle. So it's the side that goes up and down. So right here would be my apothem. And that is going to be the S root 3 side. And we already have the S side is 5, which means the apothem is 5 root 3. So I already know that the perimeter is 60, so I can find the area. So the area now is 1/2 times the apothem 5 root 3 times the perimeter, which is 60. When we put this in the calculator, because there's a root 3, we're not going to enter that in the calculator. So all we're going to enter into the calculator is 1/2 times 5 times 60, and then add our root 3 at the end. So it's going to be 150 root 3 centimeters squared. Now, number 6 already has the apothem drawn in for me, so I'm going to complete my triangle. And I know that this is not a hexagon anymore because it has 8 sides, so this is an octagon. So to find the angle, 360 divided by 8 gets us 45. We're going to divide that by 2 to get 22.5. So the angle at the top of the triangle is 22.5 degrees. So in this case, we can't use special right triangles, but remember when we have an angle and we're trying to find a side, we can use trig. So in this case, if I have 12 and I'm looking for the side down here, which is x, that's my opposite and my adjacent. So I'm going to say that the tangent of 22.5 equals the opposite over the adjacent. So remember, because the numbers on the bottom, we're going to multiply. So 12 times the tan of 22.5 equals x. So when I multiply, I get that x equals 4.97. So if this part is 4.97, the whole side, remember that we have to double that. So the whole side is 9.94. So to get the perimeter, remember that there's 8 sides. So 9.94 times 8 sides gets us a perimeter of 79.52. We already know that the apothem is 12, so the area is going to be equal to 1/2 the apothem, which is 12, times the perimeter, 79.52. And we get 477.12 meters squared. Number 7 has 5 sides, so it's a pentagon. And this time they gave us the radius, which is the slanted side. So this type of problem requires the most work because we need to find the apothem and the side of the pentagon. So what I'm going to do is I'm going to draw in the apothem and find my angle. So to find the angle, 360 divide by 5, which is 72. And then I'm going to divide that by 2 again because our triangle is in half, so 36 degrees. So I need to find 2 variables in this case. I need to find the x and the y. So again, I'm going to use trig because it's not a special right triangle. So to find x, that's the adjacent and the hypotenuse. So the cosine of 36 equals x over 9. We're going to multiply. And when we multiply, we get x equals 7.28. So our apothem is 7.28. Then to find y, we have the sine of 36 equals opposite over the hypotenuse. So again, we're going to multiply. So 9 times the sine of 36 is 5.29, which means the first part of the triangle is 5.29. We have to double it to get our side. So our side is 10.58. So the perimeter is 10.58 times 5 sides, which gets us a total perimeter of 52.9. So now that we have the perimeter and the apothem, we can find the area. 1/2 the apothem is 7.29. times the perimeter, which is 52.9. We get 1,928.21 when we round meters squared. Number 8, the measure of an apothem of an octagon is 14 centimeters and the area is 1,695 centimeters squared. Find the perimeter of the octagon. So remember that the area is equal to 1/2 apothem times perimeter. So we have 1,697.5 equals 1/2 times 14p. Half of 14 is 7. So when we divide both sides by 7, we get that our perimeter is equal to 242.5 centimeters. In number 9, the area of the pentagon is 582 millimeters squared. The measure of one side of the pentagon is 13. Find the apothem of the pentagon. So if it's a pentagon, remember that's 5 sides, so 5 times 13. When I do 5 times 13, my perimeter is 65 millimeters. So now I can use my equation to find the apothem. So 582 equals 1/2 a times 65. Half of 65 is 32.5a, so I can divide both sides by 32.5. And I get that a is 17.91 when I round, so 17.91 feet.